Here we go. Let's take a look at section 9.4, the tangent ratio. So now, as we start taking a look at the inside and outside of the triangle, we're going to begin to find the side lengths and the angles using special trig functions such as tangent. Now, what is tangent? Uh, well, let's talk about before that. We have that first definition, a trigonometric ratio, which is a ratio of the length of two sides of a right triangle. And so specifically, when we're dealing with these problems, we are talking about a right triangle. Now, what is tangent? When we say tangent sides of a triangle, it is the opposite and adjacent sides. Okay, so I'll just go ahead and put right here for tangent, I'll put opposite over adjacent. All right, and that right there is the tangent ratio. If we go down right here to the core concept, it says let triangle ABC be a right triangle. So once again, it needs to be a right triangle, or at least for our purposes right now. And then what it says is that, look, the tangent of angle A, if we look at the triangle right here, we've got three angles, A, B, and C. And so when I'm using the tangent ratio or any trig ratio, I am using the angles, the two angles that are not right. It has to be the acute angles. So right here, if we take a look at angle A, opposite would be right here, B to C. Okay, so that would be opposite, and I'll go ahead and highlight that. And then the adjacent would be side CA or AC. That would be the sides that would go with or correspond with tangent of angle A. I could also, in turn, say the tangent of B. And what that would equal is the opposite of, so let me go ahead and erase this. So if you look at the triangle right here, and I start with angle B, opposite would be CA or AC. The adjacent side would be A to B right there. And that would be tangent of angle B. All right, so all right now we're worrying about is what sides go along with tangent of a particular angle. We don't do anything with angle C because it's the right angle. And when it comes to the opposite of the right angle, it's the hypotenuse. So that does not apply to right angles in these triangles. All right. We talk about angle of elevation. You see that one right there. Hopefully that's a kind of a quick and easy definition, or at least I could kind of show you. But elevation means up, right? If you think about how high a mountain is, it's the elevation. So if we have a person down on the ground, the angle of elevation would be like the angle that the person is looking to see up on the cloud. Let's say there's a cloud up here. And so it's like, what angle is that cloud in relation to the person where they're watching, right? And so you kind of look at elevation and looking up. So that would be angle of elevation. If the person was looking downwards, then that would be your angle of depression. And we'll talk about that later on. Have your trusty calculator ready. That's going to be important right here. Scientific calculator, nothing else. You don't need a graphing calculator for our purposes. Even in Algebra 2, you're going to be using a scientific calculator. So have that handy. Make sure you know how to use it because it is very important. And every calculator happens to be a little bit different. So as we go through these problems, you may find, hey, I need to punch in numbers into my calculator a certain way for it to work. And like I said, it varies from calculator to calculator. Like a Casio, how you use that is different than a TI, Texas Instrument. So I digress. Let's go ahead and move on. Let's take a look at number 1. It says we're supposed to find the tangents of the acute angle in the right triangle and then write each answer as a fraction and as a decimal. So remember, let's start with r. Okay, so we're going to say tangent of r, and that's equal to the opposite. So opposite of that angle would be 45. The adjacent right there would be 24. All right, we want to make sure we simplify things down. We could divide that both by 3, and we're left with 15 over 8. They also say round it to 4 decimal points, and when you punch that into your calculator, that becomes 1.875, and we'll include the 0 since we're going out to 4 spots. All right, so there's that right there. All right, let's go ahead and move on to the next one. We have next, we take a look at the other acute angle. We have angle S. So this time, when we find the tangent of S, opposite will be 24, adjacent will be 45. So we have 24 over 45. Once again, we can simplify that to 8 over 15, which then equals to 0.05333 with the bar over it because it's just going to keep on repeating. All right, so it's pretty straightforward. Hopefully we got that down. Let's take a look next up at number 3. Okay, so the two angles that we're going to deal with on number 3 happen to be angles A and angle C. Right? We don't use the right angle, so that's, you look at the triangle and it's not set up the same way as number 1, but hopefully you recognize which angles you need to use. So we'll start with angle A. So I'll put tangent of A is equal to opposite, which is 2, adjacent, which is rad 2. Now, this next part is important because when we leave something in as a fraction, we never want to have radicals in the denominator. Okay? So this next step right here, I think I may have mentioned it already, but what I'm going to do is multiply top and bottom by the square root of 2. And why is that? Well, that's so we can get rid of the radical in the denominator. We have a name for this. We call this rationalizing the denominator. So if you want to see more examples of this, you need to go to Google. Okay, just Google it up. You might see it in Khan Academy. So check it out, rationalize the denominator. But what we do is we take square root of 2, we multiply it by square root of 2, top and bottom, and then because rad 2 times rad 2 becomes rad 4, which guess what? Ends up equaling that same number we have there, 2. And then we got ourselves 2 over 2. So 2 rad 2 over 2. Oh, right here the 2's cancel out, and I'm left with square root of 2. That would be the answer, the correct answer in simplest form. You're going to see problems where they say, leave your answer in exact. Give me the exact answer. That right there would be the exact answer. It's simplified. You do not have a radical in the denominator. Okay? So that would be your exact answer. You can go ahead and plug that into your calculator, and then you'll end up with approximately, looks like 1.4142. There's your exact answer. Let's go ahead and do the same thing with the other acute angle, which happens to be C. All right, so we got ourselves next. Tangent C. That's equal to the opposite, which is rad 2. The adjacent this time is 2. Okay? It's not square root of 6. You got to be careful with that. Why is it not square root of 6? Because that is the hypotenuse, and we don't use that side right now. Okay? we use that for other trig functions, but not for tangent. So we have rad 2 over 2. Great. I can leave it, and that is an exact answer because I do not have a radical in the denominator. So now, lastly, let's put that in the calculator, and we'll end up with 0.7071. And there you go. That is the tangent of side C. All right, so number 3 is a very good problem right here because of the fact that it reiterates that we need to make sure that we do not have a radical in our denominator. All right, number 4. This is where things get a little more tricky or trickier than what we've seen already. Okay, so it says find the value of x and then round your answer to the nearest 10. So we have x right here down, and I've got this angle 10. So instead of angle of a letter, let's go ahead. What I'm going to do is start off with the angle that we have right here. Okay, and so I'm going to use the tangent ratio, and I can use that because if you look at the sides that are in relation to angle 10, it's opposite and adjacent. 5 would be opposite, x would be adjacent. If they had a number up on the hypotenuse, then I couldn't use the tangent ratio, at least not yet. So let's put this all together, and I want to put tangent of the angle, and that's 10. That is equal to the opposite, which is 5, adjacent, which is x. All right? And then we just have to go ahead and solve things out. Let's get x by itself. So let's do our algebraic steps right here. I'm going to have to multiply both sides by x to begin with. That cancels things out. We got x times tangent 10 is equal to 5. And then in order for us to get x by itself, I need to divide both sides by tangent 10. And so x is equal to that fraction. Put that in your calculator, okay? Now the key thing here is most likely you're going to have to put your denominator in parentheses when you use your calculator. If you do not, you're not going to get the right answer. That leads me to one other thing right now. Make sure that your calculator is in degrees, okay? To make sure. So if you look at your calculator, you may see on the screen, like at the bottom, or like if this is your screen, you may see a D or you might see an R. If you see an R, that's not good. You need to go into the settings or the setup and change it to D, which is degrees, all right? If it's already in D, which is degrees, then you don't have to worry about the R, all right? So make sure it is in D or degrees. You might see it, your calculator may say DEG, okay? And then you're fine. If not, you have to change it or else all your answers will be wrong, all right? So that's another big disclaimer that I have for you right now. So now that we have that, you go ahead and plug this into your calculator, and x is approximately 28. Oh no. Let's fix that. It becomes 28.4, and that is the length of the side. Okay, 28.4. Okay. Let's see, what else can we do right here? Let's do number 5. It's a little different than number 4. So I'm looking at the angle right here that they show us in number 5. We have 64 degrees. I look at x, that's the opposite. 13 right here is your adjacent. Okay, so when we set things up, I've got tangent of 64 degrees is equal to opposite over adjacent. And make sure you guys show your steps on your homework and on your test. So in order for us to put all of this together right here, We got to get x by itself. This time we got to get rid of our denominator of 13, and we can go ahead and multiply both sides by 13. So in this one, when you plug things into your calculator, you got 13 times tangent 64. And that's pretty easy. But once again, it may be necessary for you to put that tangent 64 in parentheses. So now when I go ahead and solve for x, I get 26.7. All right, just like that. Easy peasy. Make sure you double check your answers in your calculator with what I have right here. Because if you're not getting the same answers, once again, you may either need to start using parentheses when you start plugging things into your calculator, or you need to change your calculator from degrees or radians into degrees. All right. Number 7. They've got a little story problem right here. It says in triangle CDE, angle E is 90 degrees. And then tangent of C is 4/3. And what is tangent of angle D, or tangent D? Well, let's start off. Let's write things out. Let's draw a triangle. And this angle right here is supposed to be angle E, right? It is a right triangle. So up here, that would be C. We have D and E. I put it that way because typically we go clockwise when we write letters, right? And from a triangle. So this would probably make the most sense. All right, so now if we take a look at angle C, let's start putting out, opposite over adjacent. Opposite would be over here, E to D, and that would be 4. Adjacent would be 3. So what they're asking you for here now is, well, what is tangent D? Well, if I look at angle D, and I look at what's opposite, opposite is 3, adjacent is 4, I have found tangent D right there. All right, let's go ahead and do a little more. These story problems, always great, especially in this chapter. It says an environmentalist wants to walk or wants to measure the width of the river to monitor its erosion. From point A, she walks down 100 feet, measures an angle from this point to point C to be 40 degrees. So what makes this so great? Well, it kind of applies things in real life and what we're doing, right? And how we could try to do something like measure something out. So we start at point A. She went downstream 100 feet, so you can see it down there. And from this point, they're saying that she walks downstream. The measure from this angle to point C happens to be 40 degrees. So I can go ahead and start plugging in 40 right there. From what we gather, right, this C to A is a straight line. It's perpendicular to the river, assuming that the river is straight. So we have ourselves a right triangle. All right, so we have that down. So we want to figure out, well, how wide is the river? Well, the width would represent C to A, and that's where I would put X. So let's see if you could put the equation together. Tangent of 40, what is that equal to? Opposite over adjacent. Hopefully you got that part down. The opposite would be X. The adjacent side would be 100. And so once again, we're just going to go ahead and solve for X. We got to get rid of our denominator there. Multiply both sides by 100. So now that we did that, go ahead, plug things into your calculator. 100 times tangent 40, and then that gets us 83.9 feet. All right, and don't forget your unit of measure. That's also another lost art or something that's forgotten many a times. All right, So let's see what part B has to say. It says, 1 year later, the environmentalist returns, same river. She walks downstream, and then this time point C happens to be a little bit different. Right, so we have A, we have C, we've got this point, but this time they're saying that from point C to over here, this happens to be 51 degrees. Right, she still goes down 100 feet. So that right there ends up changing the angle. I don't know. What do you think? Will the length from C to A be wider due to the larger angle, or shorter? Okay. Well, hopefully, if you remember some things about science, you learn about erosion. So that means things are being taken away. Well, let's see what happens. And let's see if your assumption is correct. So we'll set things up now. And I've got tangent 51 is equal to opposite over adjacent. So let's go ahead and repeat the process. We'll multiply both sides by 100. And 100 times tangent 51, that gets us approximately 123.5 feet. So there's quite a bit of erosion happening at this river. I'd be a little concerned, especially if you live close by it, because it gets us to our final answer, or the question is, how many feet has the width of the river increased? So we can, this 123.5, that's a good answer, but it's not the answer we want. So let's go ahead and figure out how much it changed. And let's take 123.5 and subtract 83.9. And so when we do that, I'll end up with, looks like 39.6 feet. And that's how much the river has increased. Quite a bit over 1 year. I don't know, maybe the current's very strong. All right, let's go ahead and move on. Next up, a boy flies a kite at an angle of 18 degrees. The kite reaches a maximum height of 300 feet away from the boy. Okay. Now, the way this is written, it can be kind of tricky. It reaches its maximum height 300 feet away from the boy. Where does that go? Does that tell me, I think what students often, how they misinterpret things is, they look at that and they think 300 feet is the maximum height. But what it's saying is that when it's 300 feet away, that's when the kite reaches its max. And that is how you'll be able to get this answer correct. Okay, so our lovely kite right here reaches its height at when it's 300 feet away. So I put 300 at the bottom. It's going to be reaching its maximum height at a right angle. And so lo and behold, we've got ourselves a triangle. And then angle of elevation right here, 18 degrees. Hopefully now you know how to solve this. Okay. You can go ahead and set things up. I'll quietly write things down right here. But tangent of 18 is equal to opposite, which is x, adjacent, which is 300. All right, once again, multiply both sides by 300 right here so you can get rid of that denominator, and then plug things into your calculator. And so once again, more practice, we get 97.5 feet. And it's not too bad, not just like that. All right. Last thing right here, number 10, find the perimeter. Okay, we got a multi-part problem right here. We got to find all the angles of the outside. Let's see if you can do that. I'll go ahead and just start this up. We have, start the triangle to the top, 33 degrees, right? We got set this up, I'll say tangent of 33 is equal to opposite over adjacent. So adjacent would be up here. I'll put an X so we could figure out what that side happens to be. Okay? All right, next up. So we go ahead, we'll get X by itself. So we got X times tangent 33 is equal to 8, but we have to get X by itself, so we'll divide both sides by tangent 33. And that's something that we did earlier on in one of the earlier examples that we did. That cancels out, and X is approximately, looks like 12.3. All right, so we've got one part. All right, next up, let's see what else we could find in this triangle here. We got 64 degrees. Let's take a look at the triangle that's down below. And we have ourselves opposite and adjacent. We don't have too much information right here. So what else can we do? Well, how about this? It looks like with this right triangle at the top, I do know 2 out of the 3 sides. So we have a thing called the Pythagorean Theorem. I want to go ahead and set that up. 8 squared plus d squared, which is 12.3. All right, that's what we just got right there. That's equal to c squared. All right. So we can figure out the entire piece right there. Start plugging things into your calculator and make sure do not round until the very end. All right, so we have 8 squared. I got 64. And then 64 plus, and then 12.3 squared right here. That gets me 215.29. And that's equal to c squared. But we didn't find our answer, right? So what do we do next? Let's go ahead and square root both sides. And looks like c is approximately 14.672. Now that is the whole entire length of the hypotenuse. When I'm finding the perimeter, however, I don't care about the whole entire length. What I do care about is this piece right there. And what does those 2 congruent signs tell me? Well, that point is the midpoint. So how about we take this number and divide it by 2. And what I'll actually find, dividing this by 2, that gets me 7.33. And that is important because that is the length of that segment right there. Okay? So now that we have that, let's go ahead and let's see what else we could find. Now that tells me that over here we got 7.33 as well. So we use that information, and that will now help us find another part of the triangle over here. And I'll put another X over there. And this problem ends up becoming a lot longer than I thought it was going to be. So just bear with me. So we have right here now tangent 64 is equal to opposite over adjacent. We'll get X by itself. We multiply both sides by 7.33. And so let's go ahead, 7.33 times, and then we have tangent 64. And I'm getting right here approximately 15.0. So right here we got 15.0. All right, last thing, let's figure out that hypotenuse. But once again, in order for me to figure out the hypotenuse, I got to use Pythagorean theorem. So I got 15 squared plus 7.33 squared is equal to c squared. All right, so I'm trying to get through this as fast as possible. I know it's a little bit longer than expected. I get 278.789, and then I'll square root that, right, in order for me to get my number, and c is approximately 17. So now we have all the sides here. Let's add everything up and let's see if what we come up with. So 17 plus 7.33 plus 12.3, right? That's what this x up here is, 12.3. And then plus a 15 plus, that is it. I get myself 51.63. Okay, so when I add everything together, I got 8 plus 12.3 plus 15 plus 17 plus 7.33. All of this gets me approximately 51.6. And that would be the perimeter of this odd shape. All right. There you go. We now went over tangent. It went over a little bit longer than I expected, but I think it was worth it. All right. There you go, section 9.4.